Okay, so let me switch on my video here. Okay, hello everyone. So welcome to the course MEEH1163. The name of our course is here. So make sure you are all in the right class. And the name of the course is VLSI Circuits and Design for 3 credit hours. And let's first go over the course outline, what the course is about, what we are going to learn throughout the semester, and what are the topics, okay, the main topics that we are going to cover during the semester. Okay, so basically you can read through the course synopsis here. So basically the course is about VLSI design, very large scale integrated design, with emphasis on designing circuits to meet certain performance criteria. So we are considering important issues when designing VLSI circuits. We are looking at the characteristics of VLSI circuits, the structure, the switch level behavior, and the current equation. And mainly we are using the MOS transistors, or the MOSFET, which is relevant today as most of the chip designs are using the MOSFETs or the FinFET, which is basically the same thing. Okay, so we are looking at the SPICE model of the MOS transistors. What are the parameters, okay, in the SPICE model to model the transistors? And we study the inverter circuit, which is the most basic VLSI cell or circuit. We study that in detail, and we expand from the inverter to create larger gates or circuits. So this postgraduate course, we emphasize on how to design VLSI circuit for speed and power. What are the factors that impact the speed of your circuit? What are the factors that impact the power? What are the power criteria? What determines the power consumption of your VLSI circuits or cells? So we explain all those in detail, and we also go into the logical effort concept on how to design a fast circuit. Similarly, effect of input signal transitions on power dissipation also will be explained. Okay, so we have the name of the course coordinator there, and we have two lecturers. I'm teaching the section 5. Okay, I'm teaching section 5 for you guys. For the Intel Penang session, Prof Abu is actually teaching the Perdana or the local UTM JB students. Okay, so before we go further, I think let me just a little bit introduce myself. So if you have not, I think maybe have not met before, but I'm currently in Singapore right now, so I'm recording in Singapore. I'm not in Malaysia now. I've been here for 2 years already. Actually, if you're watching this video during our class day, which is on the 7th, okay, our first class day on the 7th of November. So as you're looking at the video now, I'm probably on my way back to Malaysia actually. Okay, I'm leaving Singapore maybe for good on the 7th, okay, on our first day of class. That's why I'm recording and uploading this video, and hopefully on the 8th, okay, the next day we'll have a real-time live WebEx session where we can discuss further if you have questions, or we can have a look at some of the examples and so on. Okay, so basically my work is I'm actually for the past 2 years in Singapore, I'm helping an industry to work on a machine learning flow, a chip design flow for the currently I'm working on a 5 nanometer TSMC process. Okay, and I'm working on a physical design, which is a little bit higher level than VLSI. Okay, VLSI physical is still VLSI. VLSI physical design is using the concepts we are going through this class, but it's a little bit on the higher level. Okay, if you have taken, or maybe later you'll be taking VLSI design automation, that is more related to what I'm actually doing in Singapore. Okay, but I'm leaving already. Okay, 7th November. I'll be walking along the bridge, okay, the Singapore bridge to connecting JB, And then on the 8th, hopefully I'll be in quarantine. So we'll have our class during quarantine. Hopefully I will have internet and everything should be okay. If anything, I will I will contact you regarding the class and so on. Okay, so that's about me. So hopefully I will we will get to know each other. Maybe during our live session, maybe we can have a small introduction, okay, of ourselves. If there's not too many students, I'm not sure how many exactly you are yet, but I heard maybe around 20 plus. If 20 plus is quite a big class, maybe we cannot go each of you the introduction. Okay, so maybe just a few of you just to get to know, since we are not going to be meeting, right? We are probably not going to have a physical meeting. I'm not sure, maybe the last class will have a meeting, but it's still not quite sure. Okay, so it's like going to be 100% online. So okay, anyway, so what is expected from this course? Let's see what is expected. Okay, so we have the CLO, which is a course learning outcome. So what do we expect you to know, or what skill will you have after you have completed the course? So number one is this one. Okay, you should be able, after you complete the course, if you pass the course, okay, you should be able to analyze the electrical and logical properties of CMOS VLSI circuits. Okay, that includes from the basic MOSFET, inverters, and then maybe a NAND gate, and then some combinational logic, and maybe we can go to sequential logic as well. But you should be able to analyze mathematically, physically, logically how the circuit works. Okay, and we have a PLO there. PLO is a program outcome, so you can have a look on the website what each of these mean. But PLO2 is cognitive skills, okay, analytical skills. So this course should improve your analytical cognitive skills. Okay, number two is to design circuits optimized for speed and power. So we try to emphasize, because now it's important, well, especially for power, but speed is also important. How to design or how to determine if your VLSI circuits, okay, your CMOS circuit is fast and low power. Okay, what are the factors that impact the speed and power? We're going to go through that one. Okay, that one is PLO3, Psychomotor. And then CLO3 is to actually design circuit and perform analysis to meet specification with honesty, integrity. Okay, so this is basically your assignment lah. Okay, your assignment where we have to use a software. For us in the beginning, we use the LT Spice. Okay, we're going to model our VLSI circuits using the LT Spice, and after that we'll see. I'm not sure if you have access to EDA tools, because this course involves maybe layout design, and you can also do physical design a little bit. So I'm not sure yet how that's going to go, but for sure we are going to start with LT Spice. Okay, LT Spice for Spice modeling of VLSI circuits, and then some simulations. Okay, so let's go into what is PBL. I think you can read through this. Okay, so the weekly schedule. This is the weekly schedule based on the main what you call it, the Perdana mode. Okay, the UTM JB mode, and basically topic 1 until topic 5. Topic 1 to topic 5 are basic topics. The advanced topic is actually topic 6 and 7. So if you have taken VLSI design during your undergraduate, okay, UTM or elsewhere, you're probably going to go through already topic 1 to topic 5. Okay, normally undergraduate you cover from topic 1 to topic 5. So but I mean, don't worry. I mean, maybe it's a different perspective, because you have your previous lecturer is maybe different approach to my approach, to our approach here. Okay, so most likely you have not been teaching by myself, because I have not taught this course in maybe 2 years plus. Okay, so we'll see how it goes. So in UTM, if you have taken this course, maybe you have taken with a different lecturer. Okay, so I have my own approach on how we go through this thing. Okay, the material here. Okay, so it's good to have a different kind of perspective from different lecturers, right? into these topics. Okay, anyway, so introduction. The introduction actually, this is not in exam. Okay, not in test or exam. Okay, so introduction is just introduction. We're going to start with the real topic will be from topic 2 all the way until topic 7. Okay, so first we'll go through the MOS transistor, the NMOS and the PMOS. Okay, the two basic, even now 5 nanometer using FinFET. FinFET is also, is a sort of like a gate all around. It's also a kind of MOSFET actually, so it's still relevant. The MOS transistor is still relevant for now, and also I think in a few years. So we are going to look into the current, okay, the current through a MOS transistor along the channel. So what is the equation for the current? Parasitic, we're going to look at the SPICE model of the transistor, and then we'll go to topic 3, which is the CMOS inverter. So in the CMOS inverter, we are looking at the voltage transfer characteristics, what it means by the noise margin, okay, noise margin low, noise margin high, switching threshold VM, propagation delay, low to high, high to low propagation, power dissipation. Okay, power dissipation through the transistors. Okay, number 4 is circuit layout. So what is the steps in fabrication when you fabricate your chip? After designing completed the sign-off stage, right? You have a sign-off stage normally in physical design, and then your GDS or your final chip will be sent to the fabrication facility, the fab, and the fab will take your GDS, and at the end of the day you get a chip. And what is the process that goes through the fabrication process? It's very important. I mean, very interesting. And then you have the design rules. Okay, design rules normally set by the foundry. What should be the metal length, metal pitch, and so on. Stick diagram. Okay, stick diagram is a useful method to design for layout designers, especially angular path to get an optimum layout. And then we'll do a test one that covers topic 2, 3, and 4. Okay, and then we go to topic 5, which is on CMOS design. Okay, maybe Boolean equation, how to get your transistor level circuit, VLSI circuits from combination logic. Okay, complementary CMOS, and maybe we can also add sequential logic there. Topic 5b, we are going to look at pass transistor. Okay, pass transistor normally used in sequential logic. We're going to look at that, what it means by dynamic circuits, and how you size your transistors. Okay, for maybe good delay, equal low to high, high to low propagation delay, and so on. Number 6 is circuit optimization for speed. So we're going to look at the logical effort, what it means by logical effort, and what is the method to optimize your VLSI circuits, to optimize the speed of your VLSI circuit. We're going to look at the path delay based on logical effort, how to calculate the path delay, inverter change to drive load. So we're going to look at the inverter chains. And finally, topic 7, we are going to look at the circuit optimization for power, looking at the effect of the input transitions, okay, which is basically your alpha there. Your alpha is basically the probability of your input switching, okay. There's an effect of the input transitions on basically your dynamic power, okay. And then we're going to also look at the multiple threshold technique. It's a very important technique in the industry, okay. We use quite frequently. Just to be aware that you can have a design of gates or cell that has multiple VT, okay, threshold voltages, and we'll see what is the effect of that on the speed. Okay, and then we can look at the expected learning time. Okay, so how many hours should you spend on the course, right? So total meeting face-to-face hours theoretically is 42, but it's online and everything, so maybe plus minus there. Okay, plus minus 42 hours. And then the amount that you should spend by yourself is non-face-to-face is basically around 70 hours here. Okay, we are expected you to spend for every 1 hour of lecture, you want to spend like maybe 2 hours outside of lecture, to be effective and to really appreciate the course, okay. And let's have a look at this the evaluation assessments. So we're going to have two tests, test 1, test 2, and each one will be 10%, and then we have 3 assignments, 30%. Okay, but this one is total 50, yeah, so total 50. But this one is really not really fixed. I mean, we can have one test, or maybe, okay, I think most likely going to be 2 tests. In the assignment wise, maybe 2 assignments. Okay, I'm thinking 2 assignment, maybe 15 and 15. Okay, so and then you have the final exam. This is fixed. Okay, final exam is 50%, total 100. Okay, the final exam standard, if you from UTM, you know that your final exam is 2 hours 30 minutes. Okay, so that is standard. And the tools that we're going to use, I think this is Dr. Nasir. I think previously, normally he teach this course, he use Quartus and mental graphics. But for me, I think for us, me and Prof Abu, I think we are not going to use these tools. We're going to use LT Spice. And this one is for spice simulation transistor level design. But for layout design, we haven't finalized yet. I mean, we're trying to use EDA to maybe mental graphics, EDA tools, if you can have access remotely from your place. But we have limited license, and I'm not sure how we are going to use the tools with 20 plus of you in this class. So we'll see about that. Okay, we'll see about that. I think it's very important for the students to be able to know how to use the tools. But we'll see as a semester progress. Okay, so here are our books. Okay, but mainly for notes, I will upload on e-learning. Okay, all your notes will be on e-learning. So all the slides and the exercise assignments, everything will be on e-learning. Okay, and these are just basically supplementary references and books. Okay, so I think that's it. Okay, that's it for the introduction. So in the next part of the lecture, I think we go straight into the introduction chapter. Okay, which is not going to be an exam, but we're just going to skim through really quickly before, we want to look for the motivation, why we are doing this. I mean, why VLSI is important nowadays, is it still relevant, and what are the current issues now in VLSI, before we go into detail on the mathematics, the physics of VLSI circuits and MOS transistors. Okay, so I think that's it for the lecture now. Let's switch off here.